Hello viewers, in today's class we are going to discuss an important problem from differentiation, right? And this problem is related to parametric differentiation, and this is going to be an interesting problem, right? So here the problem goes like this. If x is equal to 4t cube plus 3 and y is equal to 4 plus 3 times t raised to 4, where t is some parameter and x and y are represented in terms of this parameter t, and this term is a constant, right? That is d2x over dy2 divided by dx over dy raised to n is constant. Then we have to find the value of n, right? So let us start, and here we'll apply the concept of parametric differentiation, right? So now let us first find dx over dt, right? So we have x is equal to 4t cube plus 3. So dx over dt is obviously equal to 4 times 3t square, and that is 12t square, right? And let us similarly find out the derivative of y with respect to t. So we have dy over dt is equal to 3 times 4t cube, right? And this is 12t cube. So here the derivative of 3 being a constant is 0. Similarly, the derivative of 4 being a constant is 0, right? So now let us find out dy over dx, right? So from parametric differentiation, we know that dy over dx is given by the quotient of dy over dt divided by dx over dt, right? So this is the formula for finding out the derivative of y with respect to x. Once we have obtained the derivative of y with respect to t and the derivative of x with respect to t, right? So dy over dt is our 12t cube, and here we have 12t square, right? So here 12 and 12 get cancelled, and we have 3 minus 2, and that is equal to t raised to 1, right? So we have now dy over dx is equal to t. Therefore dx over dy is the reciprocal of t, right? That is 1 over t, which can also be written as t raised to minus 1, right? Because see, here we have to find dx over dy, right? So dy over dx is t, so the value of dx over dy is the reciprocal of t, that is 1 over t, which can be written as t raised to minus 1. So we have to use this result, and now let us find out the value of d2x over dy2. So now to find out the value of d2x over dy2, what we will do, we'll differentiate both sides with respect to y, right? So what we will have, d by dy of dx over dy, and here we have d by dy of t raised to minus 1, right? So now this becomes d2x over dy2, that is the second derivative of x with respect to y, and here we have to differentiate t raised to minus 1 with respect to y. So for this we'll make use of the chain rule. So we have d by dt of t raised to minus 1, and here we have dt over dy, right? And the derivative of t raised to minus 1 is minus 1 over t square, and for dt over dy we can use the expression from this value, right? So here we have dy over dt is equal to 12t cube, so dt over dy is 1 over 12 times t cube, right? So here we can substitute the value of dt over dy. So we have 1 over 12 t cube, right? So this is minus 1 over 12 times t raised to 5, right? So the value of the second derivative of x with respect to y is given by this expression, right? And we have already obtained this one. So now let us see the condition here. So here d2x over dy2 divided by dx over dy raised to n is given to be a constant, right? And we have to find the value of n. So now d2x over dy2 divided by dx over dy raised to n can be written as, see, the value of d2x over dy2 is this. So we have minus 1 over 12 t raised to 5 divided by dx over dy is t raised to minus 1. So here we have t raised to minus 1 raised to n. So this is minus 1 over 12 t raised to 5 multiplied. We have 1 over t raised to minus n, and now this division is converted into here multiplication. So we have this term, and now this can be written as minus 1 over 12, and if we take both these t's to the numerator, we have t raised to n minus 5, right? So now the value of this expression is equal to this one, right? And see here what we are given in the problem, that this expression is constant, right? So in order to be this expression to be constant, what we have to do, we have to take n minus 5 is equal to 0, right? So once n minus 5 is equal to 0, it means the value of this expression would become minus 1 over 12 t raised to 0, because n minus 5 is equal to 0 and t raised to 0 is equal to 1. So we have minus 1 over 12 times 1, that is minus 1 over 12, and this is a constant, right? Because this is independent of the parameter t, right? So in order to get this condition, that is this term to be a constant, this power must vanish, right? So n minus 5 must disappear from here, so n should be equal to 5, right? So for n is equal to 5, this expression is constant, where x is 4t cube plus 3 and y is 4 plus 3 times t raised to 4, right?